Hi everyone, in this video we're going to go over a review of the trigonometric functions in reference angles. So first we're going to find the values of each of the functions and the special angles that we define. So as always, we can start with sine and cosine at 0, sine at 0 is 0, cosine at 0 is 1, and then backwards we have that sine and pi half is 1 and cosine of pi half is 0, and so we have an incremental situation going with the sine, and we have a decreasing going with the cosine. So we put the 1 here, we go 1 2 3, and we go in this direction 1 2 3, then we take the square roots, and then we divide by 2. And so now we have all the values here for the special angles of sine and cosine, and then we're going to use the definition of tangent. Remember, tangent is sine over cosine. We also have that cotangent is 1 over tangent. We have the secant is 1 over cosine, and we have that cosecant is 1 over sine. So now if we have that tangent of 0 is sine over cosine, so sine of 0 is going to be 0, so tangent of 0 is 0 as well. Cotangent, of course, is not going to assist, so do not assist. Secant is 1 over cosine, so that's going to be 1, and cosecant did not assist either. Same thing over here. If we have tangent of pi half, because cosine is 0 here, then tangent does not assist. And also secant that also has cosine on the bottom does not assist. And now cotangent, cotangent is cosine over sine, so essentially is going to be 0. And cosecant is 1 over sine, it's going to be 1. Now all the other ones are going to be flip versions of this. So for example, over pi over 6 this is sine over cosine. Sorry, we left this one. This is 1/2 here. And so sine over cosine is 1/2 over square root of 3 over 2. So this is going to be 1 over square root of 3. Tangent is going to be 1, since these two things are the same. And with a square root of with pi over 3, we have a square root of 3 over 2 divided by 1/2, which is going to be square root of 3. Now cotangent is just 1 over tangent, so this is going to be square root of 3, 1, and 1 over square root of 3. Secant is 1 over cosine, so we're flipping the values of cosine. So 2 over square root of 3, 2 over square root of 2, and 2. And 1 over cosecant is going to flip the values of sine, so we have 2, 2 over square root of 2, and 2 over square root of 3. And so those are all the values that we can get for special angles. Always remember that you need to remember the definition between tangent, cotangent, secant, and cosecant, and they can all be expressed in terms of sine and cosine. For example, even cotangent, that is 1 over tangent, can be written as cosine over sine. Now let's use this to get some values of the unit circle. So for example, we got cosine of 5 pi over 4. You just got to remember this is with special angles in reference angles, of course. So the reference 5 pi over 4 is what? 5 pi over 4 is in the third quadrant, since it's a little bit more than pi. It's 180 plus 45 more, so it's like 225, so that's in the third quadrant. And in the third quadrant, cosine is going to be negative, so this is minus cosine, and the reference angle is going to be pi over 4. Since this is ending in pi over 4, the reference angle is going to be pi over 4. And because it's in the third quadrant, we have a negative, so minus cosine of pi over 4, so minus the square root of 2 over 2 according to the special angle tables. Now, sine of 4 pi over 3. 4 pi over 3, again, is also something that is on the third quadrant. In the third quadrant, sine is also negative, so this is going to be minus sine of pi over 3. In pi over 3, the sine is square root of 3 over 2, so this is going to be minus the square root of 3 over 2. Cosine of 15 pi over 4. Notice that's if we have 16 pi over 4, 16 pi over 4 will be 4 pi. So this will be close to 2 turns around. So I can think that this is angle that is going to be equivalent first to another angle on the first unit circle. So I can subtract a couple of 2 pi cycles. So if this is equals to cosine of, and let's first subtract the first 2 pi cycle. So if I subtract 2 pi, I'm really subtracting 8 pi over 4. So 15 minus 8 is 7 pi over 4. So this is my angle on the first unit circle. 7 pi over 4. Remember, 8 pi over 4 is just 2 pi. So now with this, we can remember that this is actually on the fourth quadrant. And so because it's in the fourth quadrant, cosine is going to be positive. And this is cosine of pi over 4, which is the square root of 2 over 2. Now this is 13 pi over 3. So in terms of pi over 3, 2 pi is what? So 2 pi is 6 pi over 3. So if I subtract 6 pi over 3 from this, I'm going to get 7 pi over 3. And if I subtract again another 6 pi over 3, I'm going to get pi over 3. So at the end, this angle is coterminal to 7 pi over 3 is coterminal to pi over 3. And so because this angle is in the first quadrant, then I don't need to do anything in particular, and this is just going to be 1/2. Now continuing with this, cosine of 3 pi. So 3 pi is an angle that is coterminal to cosine of pi. If we subtract 2 pi, we realize that we're really talking about cosine of pi on the unit circle, and this is just going to be -1. Since when we have angle pi, we're in the point -1, 0, so -1 in cosine, 0 in sine. Sine of 3 pi then will be equivalent to sine of pi, and we have that is 0. Now we have cosine of 100 pi over 4. So 100 pi can be seen as 25 pi, right? And 25 pi is like, we can think of it as pi plus 24 pi, or pi plus 2 times 12 pi. Sorry, actually backwards. So I can think of this as 12 times 2 pi. So notice that we're turning around 12 times, and then with 2 pi, and then we're going to get pi. So this is equivalent to just cosine of pi as a coterminal angle, and this is just going to be -1. Now similar cosine of 100 pi over 3. So 100 pi over 3, I can see this as 99 pi over 3 plus pi over 3. So now this 99 pi over 3, I can see it as 33 pi plus pi over 3. And now I would like to see this as something that is even, so 32 pi plus 4 pi over 3. Now this 32 pi, I can see it as 16 times 2 pi plus 4 pi over 3. So notice that this is like we're turning 16 times around the circle and we end up in 4 pi over 3. So this is equivalent to the coterminal angle 4 pi over 3. And so now 4 pi over 3 can be something that we use a reference angle. So 4 pi over 3 is going to be on the third quadrant. So this is minus cosine of pi over 3, since in the third quadrant cosine is negative. Now cosine of pi over 3 is going to be square root of 3 over 2. And so notice that all this finding angles on the unit circle, they use special angles. They use the special angles here, but we do quite a few things. We can either use coterminal angles to just find angles on the original unit circle and then find the reference angles to actually get to the last point, or we simply use the reference angle when it's possible, or we get with a coterminal angle to an angle that we already know what the value is. So now for another type of question that we can do, we can use the reciprocal or Pythagorean identities to find other trigonometric values when we're using the information about one of the specific identities. So for example, here we have sine of t equals 2/3, and we have that the terminal point of t is in the second quadrant. So this is giving me information about how the numbers are. So in the second quadrant, x is supposed to be negative and y is supposed to be positive. This is in quadrant 2. So this is going to give me some information about the sign. The sign is supposed to be positive, which matches, right? Y bigger than 0. But x less than 0 is telling me that cosine is going to be a negative number. So that's important because now what we're going to do is we're going to start from the identity cosine squared plus sine squared of t equals 1. But then we know that sine of t is 2 over 3. So we have that cosine square of t plus 2/3 square is equals to 1. And so cosine square of t is just 1 minus 2/3 square. If I simplify this, this is 1 minus 4 over 9, or I can see this as 9 over 9 minus 4 over 9, or 5 over 9. So this means from here that the cosine of t, if I take a square root on both sides, is going to be plus or minus the square root of 5 over 3. But because we know that the cosine is negative, then we just get cosine of t is minus square root of 5 over 3. Now at this point, I can find all the other trigonometric identities that I'm missing. So for example, tangent of theta is going to be, or tangent of t in this case, is going to be sine of t over cosine of t, and the sine of 2 over 3, and the cosine is minus the square root of 5 over 3, so this is just going to be minus 2 over square root of 5. The cotangent is 1 over tangent. It's 1 over tangent of t. And so that means that I can flip around these values here. And this is going to be minus square root of 5 over 2. Now, secant is 1 over cosine. And because we just found that cosine was this minus the square root of 5 over 3, then this is going to be minus 3 over square root of 5. And finally, cosecant, which is 1 over sine, is going to be 3 over 2. That's something that we have from the original hypothesis. So that's one way of achieving this. Of course, there's another way where you can just simply relate this to the triangle to find the values. And so you can think that this is like opposite over hypotenuse. So you get this, and you're assuming that this is t. And so you're eventually going to find out that by Pythagorean triangle, 3 squared plus, let's say this is x squared equals 2 squared. And so from here you're going to find that x is equals minus the square root of 5 at the very end. This is 4 minus 9. Sorry, this is hypotenuse square. So this is backwards. So this is 3 squared is equals to 2 squared plus x squared. So this is 9 minus 4. X squared is equals 5, and so x is minus the square root of 5, which matches with the information that we have from the cosine. And so from here you can get all the other trigonometric identities if you're using the triangle, which is going to lead you to the same place. Now let's talk a little bit about transformation of the functions. So we define that we have a function y equals a sine of b x minus c, and if you will, we might even have a d here, and this is the horizontal sheaf. Sorry, this is the vertical sheaf. This is the vertical sheaf here. So up or down. This one here, C, is the horizontal sheaf, which is going to be left or right. This is the speed that determines the period, where the period is 2 pi over b. And this is, of course, the amplitude of the wave. So this is a lot of what you're going to be seeing on the activity for today. But all this part is the anatomy of these trigonometric functions. Now here we want to find out the amplitude and the period of this. So the amplitude for A is equals 1, regardless if it has a negative or not. That doesn't matter. Because we're taking the amplitude is the absolute value of A. Now the period is 2 pi over b. In this case is 3, so 2 pi over 3. For b, we have y equals cosine of 4 pi x. So we have again that the amplitude is 1, and we have the period being 2 pi over 4 pi. So the period here is actually going to be 1/2. For c, the amplitude is 2, and we have that the period is 2 pi over 2 pi, so it's going to be 1. For d, we have that the amplitude is 5, and then we have that the period is going to be 2 pi, and we divide by this number 3 here. Notice that this 3 is multiplying the x is still the v. If I were to separate this or to put it in this form, this will be 5 sine of 3x minus pi over 12. That'll be the right form to put it just exactly as this. But we're only finding out amplitude and period, so that doesn't matter for now. In E, we have that the amplitude is 2, and then we have that the period is 2 pi over pi. So it's actually the period is 2. Okay. Make sure to always be using this 2 pi over b, where b is this number. That's how you find periods. Now let's go to question 5, and in question 5 here we're going to talk about horizontal sheaves. So sometimes it's evident in this case, for example, the horizontal shift is just pi half. You can see here that is x minus pi half, so that's the horizontal shift. In this case, it's not that obvious, and we actually need to factor out some numbers. So notice that we need to factor out 3 pi, and so if we factor 3 pi, we get an x here. But from here, factoring this pi is going to leave me there, but factoring a 3 that I don't have is going to mean that I'm going to have 1 over 6 over here. And so far this is cosine of 3 pi times x plus 1 over 6. But that still is not telling me the horizontal shift, so I need to put the minus in there. So this is x minus 1 over 6. And so now I can see the horizontal shift. The horizontal shift is actually c equals minus 1 over 6. So we're shifting minus 1 over 6 units to the left. A similar thing happens here on c. Notice that what we can do is we factor out that 3, and we get sine of 3x plus 1. But we can see this as 2 sine of 3x minus 1. And so we actually can see that the horizontal shift is c equals minus 1, or we're moving 1 unit to the left. D, we have 3 sine of x plus pi over 4. So we can see this as 3 sine of x minus pi over 4. And so that implies that the shift is actually minus pi over 4, or we're shifting pi over 4 units to the left. In E, we do a similar thing. We factor pi as well. So when we factor pi, we get x plus 1/2 in here. And if we put the minus out to check the shape, this is going to be x minus 1/2. And so that's going to imply that the shift is actually c equals minus 1/2. And again, this is another shift to the left 1/2 units. Okay, so this is a couple of examples of how to do transformation with the trigonometric functions, whether they're sine or cosine, and getting back a little bit on the reference angles and how to find all the trigonometric functions given that we have all the information for a particular angle and information about the quadrant. Okay, so that concludes the class that we have for today, and just make sure to check the other video about more transformations and to complete also the activity for the day.